In this lesson, we're going to take a look at what happens when my user tries to browse the website www.rtsnetworking.com. From my user's computer, RTS Client 1, the first thing the computer does is check its local client cache. That client cache contains name to IP resolution for any websites or any servers that you have recently connected to. If you have not connected to the rtsnetworking.com website within the past few minutes, it's not going to be in cache. If it's not in cache, the second step is to check the local host file. The local host file is present on all machines. I can open the C drive, Windows, System32, drivers, and the ETC folder. In that folder will be a host file. The host file is a static version of DNS. It has name to IP addresses typed directly in the file. Any entry in the host file, your computer will always resolve the name to that specific IP address. Host files used to be common long ago, in the days of Windows NT, Windows 2000. They're not extremely common now, but the host file is still a part of the resolution process. If the entry I'm looking for is not in the local cache, if it's not in the host file, the client computer knows it cannot resolve this name. The next thing the client will do is pass a recursive query to the local DNS server. The recursive query simply means the client asks the DNS server to resolve this name on its behalf by any means necessary. If that requires the DNS server to contact other DNS servers to resolve the name, that is what the client expects the DNS server to do. So the onus is completely placed on DNS to resolve this name. The DNS server itself, the first thing it will do is determine if the name you are connecting to is a local name or if it's a remote name. A local name means the name you're trying to resolve is a name that's in the domain that you're actually in. If my domain is named fabricam.com, if I'm trying to resolve a file server or a web server in my domain, then my local DNS server actually holds that record. If I am trying to resolve anything outside of fabricam.com, any website on the internet, for example, my DNS server does not hold those records, and it has to query other DNS servers to have that resolved. So in our example, this is a remote name. One of the concerns we always have with DNS is how many queries it receives and how much stress is placed on the DNS server itself. The fifth step in the process is for the DNS server to check its own local cache. The point of the DNS server cache is to offload the stress on the DNS server itself. For example, let's say my coworker went to rtsnetworking.com a few minutes ago. Now I go to rtsnetworking.com. The DNS server will simply check its cache to see if it has resolved this name for any other users on the network. If it has resolved that name and it still resides in cache, it will simply retrieve that from cache and send it back to the client computer. In the example here, we will assume we are the first person that's going to rtsnetworking.com, so it's not in our cache. Step 6 is an iterative query, often referred to as a simple query. This iterative or simple query will pass a request to the root of the internet. The root of the internet is always represented by a dot. That root is actually a collection of DNS servers that hold all the records for all the internet-based public top-level domains. The .com, net, org, all the domain extensions you see on the internet, they are all referenced from this root domain. So in practical terms, what that means, my DNS server queries the root and says, I'm trying to get to rtsnetworking.com. Can you tell me what IP address that resolves to? Well, the root says, no, I can't directly tell you that RTS networking resolves to a certain address, but what I can tell you is you should go query this other group of servers. They hold the .com namespace. every publicly registered website in the world that ends in .com, they would have a record for that website. So my local DNS server receives that response. The local DNS server will then query the .com namespace, specifically looking for RTS networking. The .com name servers will have a public host A record for that. So those servers know that RTS networking has an IP address 23.236.62.147. That is sent back to the DNS server. Now my DNS server is aware of the IP address that rtsnetworking.com, that name, we now know what address it resolves to. Step 10, the DNS server will place that response in cache. So in the event a coworker attempts to browse that same site a few minutes from now, the DNS server does not have to reach back out to the internet, communicate with the root, and go through that same resolution process again. So it'll be temporarily stored in cache. Step 11, that resolved name to IP address is now passed back to the client. Now the client knows the IP address of rtsnetworking.com. Many of the things I just touched on in this graphic, we can actually interact with in the interface. So in the next lesson, we will look at the local client cache in step 1, and we'll see how we can manipulate that and how we can view the contents of it. I will also show you the host file and how we can add an entry into the host file and exactly how that process would actually work. On the DNS server, we will also examine the DNS server cache, and we will look at the root hints to see how they are defined on the DNS server itself. Now let's take a look at that lesson.